everybody, welcome to my channel. Today, a very good problem you guys call convert sorted array to binary search tree. So this is a very classic one, right? So let's quickly read the problem statement, right? So it says given integer array nums, right, where the elements are sorted in ascending order, converted to a height balanced binary search tree, right? So we'll be given an array called nums, right? This is what we give it as input, and our job, right, is to convert it into a height balanced binary search tree. So it has to be balanced, right? And it has to be a binary search tree, right? So binary search tree, we know that on the left side of every node contains elements smaller than that node, right? And then to the right of it are elements bigger than that node, right? So the left subtree is all contains values less than the root node, and the right subtree always contain values are greater, right? So we know what the binary search tree is, right? It has to be balanced, right? So they did a great job explaining what exactly balanced, right? If you don't remember from your classes, right? It says a binary search tree is a binary tree. A height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one. So this is a very, very important one, right? So that the depth or the height, right, of the subtrees, right, can not differ more than one. The difference between them, right, cannot differ more than one, right? So let's say, for example, right, we're given the 5 was at the top, right, which would push 0 down, right, and then the 9 would have pointed at 5, right, on the right side. So now we would have had all the elements pretty much leaning in mostly on the left side, right? It would be leaning too much, which wouldn't be good, right? Because the height of this would have been 0, right? The depth would have been a lot greater, right? Which we have 1, 2, 3 nodes on the left side, and we would have only had the 9 on the right side, and it would differ by more than one. So we know that it wouldn't be balanced, right? So this would not have cut it. Okay, so it has to be balanced exactly like that, right? And also, right, so there's not only one answer, there's all other ways we could have it as well, right? This is another way, right, that we could have it as well. This is also an acceptable answer, right? So pretty much the gist is we're given an input in this sorted array, right, ascending order, and our job is to return the pointer, right, to the root node of the binary search tree, right, the height balanced binary search tree, right? Return that to the caller, pretty much, right? That's kind of what we need to do. Okay, so how can we go ahead and solve this, guys, right? And also we need to come up with a clever way to do it. So how is the easiest way? Do we just do a linear loop through the thing and add stuff as we go along, right? So I'm thinking we have -10. We get that node, then we go on to the next node, we make that point to the new node we create for this one, right? And then now it's not going to work, right? And this node points to this node, right? Because right now, the way I'm talking about, we will create a linked list, right? Which is now what we want, right? We want to make sure that things are balanced, or to the everything's like balanced, essentially, right? So this linear loop is not going to cut it. So we got to think about it a little bit in a clever way, right? So how do we make sure that things are balanced, right? We have this, like, an even amount of nodes on the left side and even amount of nodes on the right side. That's kind of the bottleneck here. That's kind of what we want, right? Maybe what I'm thinking, how about we just create that as we go along, right? I mean, that's kind of what we want. Why don't we start with that originally? Okay, so where I'm getting at, right? So we know that the sorted array is like, the array is sorted, right? So how about we just pick the middle element? And we know about that middle element, right? There's going to be even amount of elements on the left side and even amount of elements on the right side, and we know that the array is sorted, right? So we know everything on the left is smaller than that particular element, and everything to the right of the element is greater than that element, right? Which perfectly fits into that binary search structure that we're trying to create, right? And not only that, it makes it easy to do it like that, right? It also maintains the balance thing that we're trying to do, which is have an even amount of nodes on the right and even amount of nodes on the left side, make sure everything's fine, right? So it's kind of what I'm trying to do here. That's exactly what I'm going to do. So we start off with 0 to be the root node, right? That's a fair one, I'll say. And then we recursively, right, create our subtrees. All right. So for this guy, so we know that for the whole array, right, this is going to be 0 is going to be the root node, right? So now the root node, all right, cool. I'm the root node. So now also create my left side for me, right? So we call the same function, right? It's a recursive function. And this function is going to do exactly the same thing, right? It's going to create, right, a balanced binary search array. It takes the middle, so out of those two elements, right, it does a binary search, right? So that's how we're gonna do it, pretty much, right? To find the middle element, we're gonna do a binary search. Because binary search to find the middle element, right? So apply the formula. Now we would just like pretty much, whatever the length is of the. So we'll also pass it boundary so that it knows that exactly the boundaries that it's looking into, right? So originally it'll be the full array, and then as we do things in a recursive manner, we would like update the boundary, right? So let's say we want to create our left side, right? For our left side, it would be from the left. So originally for the whole array, right, we have the left boundary starting at the beginning and the right boundary starting at the end, right? And then once we create our left, we want to create a left boundary, right? We pass in those two parameters. We pass in the left side, which is the beginning of the array, all the way up to the mid -1, right? So pretty much the middle element -1, so not including that middle element, right? So we apply the same thing formula here to find the midpoint, right? So we find the midpoint. For this one would be the first element, right? Whichever one we choose, first element. Then you create that, boom, it goes to the left side. There's nothing to its left, so there's nothing needs to add, but there's a -3 to its left, so it creates that -3 right there, right? Once you keep updating the boundaries, that's kind of how we're solving. I think the code will make it a lot simpler for you guys. So I think it'll be good. So let's quickly go ahead and create it really quick, right? So let's just do this. Let's just do a return helper. We're gonna pass in. There's no nums. We also pass in the left boundary, which is 0, and then we're gonna pass in the right boundary as well, right? All right. So this is our thing right there. So let's just create our thing real quick. So we have tree node, helper. So we're gonna pass in those parameters, which is the nums thing. Left boundary and a right boundary. Okay. So now we're going to do a check, right? If we're given, right, so the left is greater than the right, right? We're across the origin, we know that, there's no elements there, right? So because two pointers have crossed over, so the return is null, right? So this would have been the case where for -10, we try to go to the, right? So the left crosses over, return null. All right. So what's next for us is to calculate the midpoint for this particular, right? Left plus right minus left divided by 2. That will give us the midpoint, right? So now that we have that, right, we can create our tree node. Tree node is equal to new node. Right. We're going to pass in the middle element, right? So we need to get the value from the array, right? So we get that, we calculate that, and then we can call that on our left side. We're going to build that left, go to helper, we're going to pass in the original nums array, and then now, like we said, we're going to pass in the left boundary, and up to the right boundary is going to get updated to mid -1, right? Okay. And then we know that, right? Go to helper, pass in the nums array, right? Then we'll do a left. No, we don't do left, right? We do mid +1, right? Because that's what we want to do. So mid +1, all the way up to the end of the array, right? The right boundary. Okay. And then after that, we can return our node, right, to the color. So we calculate the midpoint, right? We create the value for that particular node, right? So we create 0. And then for our left side, we just pass in those parameters, right? From the left side all the way up to midpoint, -1. You can create my subtree for me, right? And then just like this one does that, right? And think about every node is going to end up doing that for each of the respective subtrees. Okay, that's kind of how they're going to pretty much create that recursively and makes this elegant solution work, right? So let's press run code, see we passed the small test cases. Okay, looks like we did, guys, right? Let's press submit. Awesome, guys. Looks like we passed all the test cases. So if you guys found value, you guys understood the thought process, you guys, you really enjoyed it, in the comment section. If you guys are new here, make sure to subscribe, because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.